Welcome to this overview of the Dynamic Number Project. The Dynamic Number Project offers 70 free interactive models for grades K through 11 that focus on number, operation, and early algebra. All of these models have been built for the Geometer Sketchpad and include extensive support, including teacher notes, worksheets, Common Core connections, and getting started videos. Let's take a look at just a few of the many innovative models available for your classroom. This 10 frames model allows students to add counters to each of our 3 10 frames. Students can then drag counters from frame to frame, making it easier for them to determine the total number of counters. Here we have a number chart, and students can use this to add and subtract using mental mathematics. They can choose whether to add values of 1 to their current location on the chart, or they might choose to add 10. Using this chart, students can explore mental mathematics approaches to addition and subtraction. Here we have a bunny on a number line, and this provides another context for exploring addition and subtraction. In this case, students can make jumps of 3 or 5, and they're also able to change the values of these jumps so that they can model addition and subtraction problems. We can even take hops of negative values. Here we have an open number line, and this rounds out our approaches for addition and subtraction. This open number line provides a simple yet powerful model for taking a problem like 17 plus 78 and breaking it apart. For example, we might represent 78 with adding 3 to 17, and then 5, and then finally 70, just with a few clicks of our mouse. Now we'll move on to multiples and factors. This dynamic number grid allows students to view the multiples of any 2 numbers simultaneously, in this case 3 and 4. Those numbers that are shaded half orange, half blue are common multiples of 3 and 4, with 12 being the least common multiple. Students can easily change the dimensions of this grid, and they can even change the 2 numbers whose multiples we're examining. For instance, I can change the 4 to a 7. No problem. This factor array displays all the factors of 32 in blue, 1, 2, 4, 8, 16, and 32. But we're not limited to 32. We can view the factors of any number, and this allows students to search for patterns very easily. Here we have bugs that are scattered across the screen. How can we determine how many bugs there are? Well, let's have them fly home. When they're home, students can connect the arrangement of the bugs to a multiplication problem, allowing them to determine the total number of bugs. Here, we have base 10 blocks, and these provide another way to think about multiplication. Here we see 26 times 24. But we're not limited to 26 times 24. We can drag these points and model other problems as well. Here we have an example of what we call a color calculator. The fraction 1/4 is represented in decimal form as 25/100ths, with lots of zeros to the right of the 5. Students can choose to explore the decimal representation of any fraction less than 1. For example, 1/7. In this case, they see a wealth of colors, a rainbow of colors, with each digit represented by its own unique color. These colors make it easy for students to search for patterns as they change the dimensions of this array. Here, for example, we can see that the fraction 1/7 keeps repeating 142857 over and over again. Here we have a point, a red point, sitting on a number line. Students estimate its location, and then they zoom in. They magnify the number line so that they can see the interval between 5 and 6 divided into tenths to make it easier to determine the location of this same red point. They apply this idea over and over again, zooming in from tenths to hundredths, from hundredths to thousandths, and from thousandths to hundred thousandths. They can also explore what happens when they drag the red point to other locations or animate it. Have you ever wanted an easy way to make accurate visual representations of fractions? Well, with our dynamic number models, you can. With just 2 clicks of a mouse and my Make Fraction tool, I can make any fraction using these numbers as my numerators and denominators. For example, 11/80ths. And I'm not limited to fractions that are less than 1. Perhaps I want to see 36/15ths. No problem. In this game, Sketchpad gives students a quadratic to factor, and they use this grid to help them visualize the results. Here I can factor this as 3x plus 5 and 2x plus 3, and then check my answer. Finally, a series of activities focusing on functions introduces the concept of function by treating geometric points as independent and dependent variables. These activities and many more can be found on the Dynamic Number website, dynamicnumber.org. Check it out.